Now let's talk about some simple vector operations. Before you put pencil to paper, let me show you a visual of adding two vectors. If this is vector u, I will graph it. And this is vector v, I will graph it. In order to visually represent addition of two vectors, I will take the second vector, the green one, and move it to the terminal point of the first vector. So what we're doing is we're taking vector u, and from there adding on vector v. This new location, which is at -4, -1, is the result of adding two vectors together, and we call that a resultant vector. Now you're going to be doing vector operations mathematically or algebraically. So let's look at that approach. In order to add two vectors, we'll take vector u plus vector v. We add x components, and then we add y components. 2 plus -6, those were my x components. -9 plus 8 were my y components. And there's our vector. Let's subtract. Pay attention to the order. Starting with vector v, we will subtract vector u, which means we subtract x components, -6 minus 2, and we subtract y components, 8 minus a -9, to create a new vector called a resultant vector, the result of subtracting two vectors. In this next example, what looks like coefficients are actually called scalars. We worked with scalars in our matrices unit as well. So I will multiply the components of my vector u by -2 and multiply the components of my v vector by -3. And after I've done that multiplication, -2 times 2, -2 times -9, -3 times -6, and -3 times 8. Because I've already multiplied by the negative, my next step is to add components to get my resultant vector. In the last example, we start with vector u. We have a scalar of 1/2 times vector v. Add components to get a resultant vector.